So the limit f of x approaching negative infinity is 0 because the orange line does not touch a 0 and it goes into negative infinity. The limit f of x approaching negative 2 to the negative side is infinity because the negative 2 is the vertical asymptote and the line goes all the way up. Okay, so the limit of f of x approaching negative to a positive side is 1 because when you go to the graph and go to negative 2, you can see that the y is 1 in the positive side.
Limit f of x approaching to negative 2 does not exist because as you can see it has no sign and it needs to be approaching from both sides. So the answer will have to be the same limit.
The limit f of x approaching 1 is 4 because there are two lines approaching that number. Remember, don't get confused by the points on the 6 because there is nothing approaching it and it is just a point.
F of x approaching to 2 is number 3 because as you can see in the number 2, as you go up, that's where the line is passing by.
So this problem is asking you for the lower limits of the population. First, you will start by getting the asymptotes. You will equal this to 0. So this will be the result of your vertical asymptote. So then you will need to get the horizontal asymptote. To get the horizontal asymptote, you will need to check degrees of both parts of the fractions. As you can see, on the upper part, there is no degree. And as the rules say, when the degree is bigger on the denominator, the horizontal asymptote equals to 0. So to picture things better, we will start making a graph. And we will take x as your time. So the horizontal asymptote will be 0 and the vertical asymptote at -1. So by watching the graph, you could say that your limit is going to be positive infinite.
Now back to the equation. To work with it, we're gonna have to expand the denominator. So it's gonna be plus. We're gonna expand to t, 2 plus 2t plus 1. So now when x is approaching to the infinite, you're gonna have to work with the biggest degree on your denominator. So you're gonna divide everything by it. Over t2 and the same on the denominator. So now you have it like this. You're gonna start to cancel everything out. Here you cancel both. Here you cancel 1t, and this one stays the same. Next, every t is gonna become an infinite. So it's gonna be 8,000 over infinite over. This becomes a 1, then 2 over infinite plus 1 over infinite. Now all of our infinites are gonna become 0. 1 plus 0 plus 0. So here it's gonna be plus 0 equals, and this is gonna be our answer.